Hey there! In this month's edition of The New Scientist dated July 31, 2021, there was an article that looked at how thin air therapy helps the body. It explores that oxygen is needed for tissue and organ to survive and that the body can adapt to variance in oxygen. Hypoxia is beneficial in some situations and harmful in others. If you are looking for more fascinating information on the hypoxia, continue listening on as we go through the article. Thin air therapy. Our organs and cells die without enough oxygen, but there may be times when limiting it could actually help us heal. Ute Eberly investigates. Mountaineers Ralph Dujmovitz and M. Nancy Hansen are no strangers to thin air, having collectively reached the summits of all 8 of the world's highest mountains. But when they entered the hypoxia chamber at the German Aerospace Center, DLR, in Cologne in May 2018, they were effectively climbing one of the highest peaks of their careers. After a 2-week acclimatization, they spent 16 days breathing air thinner than at Everest Base Camp, including 4 days at the equivalent of 7,112 meters. This is just shy of the death zone over 8,000 meters, where the lack of oxygen impairs climbers' judgment and increases their risk of heart attack and stroke. Time and again, the 2 mountaineers and those observing them questioned perplexed and panicked doctors, and treatment guidelines recommend giving extra oxygen after a heart attack or stroke. People are routinely given oxygen too, to ensure their tissues don't die. Yet, for all this, surprisingly, there are hints that hearts and spinal cord injuries could heal faster if deprived of oxygen. Could it be that, in some cases, at least, we have been breathing too much of a good thing? Our bodies are set up to adapt to variations in oxygen availability. The 2019 Nobel Prize for Medicine went to the British and US researchers who identified key molecules called hypoxia-inducible factors, HIFs, that whether they should keep going, but they did. People living. If Dujmovitz and Hansen could show that humans can tolerate extended periods of low oxygen, known as hypoxia, it would pave the way for an even more ambitious experiment, to test whether, sometimes, it might even be beneficial to starve people of oxygen. This may sound strange. After all, our organs and tissues need oxygen. Indeed, astonishingly low oxygen levels in people with COVID-19 have perplexed and panicked doctors, and treatment guidelines recommend giving extra oxygen. After a heart attack or stroke, people are routinely given oxygen too, to ensure your tissue don't die. Yet for all this, surprisingly, there are hints that hearts and spinal cord injuries could heal faster if deprived of oxygen. Could it be that, in some cases at least, we have been breathing too much of a good thing? Our bodies are set up to adapt to variations in oxygen availability. The 2019 Nobel Prize for Medicine went to the British and US researchers who identified key molecules called hypoxia-inducible factor, HIFs, that multiply when oxygen supplies run low. HIFs activate hundreds of genes and biochemical pathways to help cope with oxygen deficiency. At least some of these adaptations seem to be beneficial. Almost 140 years ago, French physiologist Paul Bert hypothesized that exposure to high altitude increased the number of oxygen-carrying red blood cells. In the 1930s, Russian military pilots prepared for flying planes with open cockpits by undergoing altitude acclimatization. During these sessions, doctors noticed that bouts of hypoxia seemed to help with conditions ranging from asthma to hypertension. That's directly at odds with the conventional medical view of hypoxia. When people head into the mountains, their hearts beat faster, and their blood pressure increases as their bodies try to cope with the diminished oxygen supply. They may feel nauseous, experience headaches, and struggle to concentrate. Severe altitude sickness can be deadly, as the brain swells and lungs fill with fluid. Even so, people living long-term at altitude seem to be healthier, on average, than those living near sea level. They have lower rates of diabetes, cardiovascular diseases, and certain types of cancer like breast cancer and lymphoma. Now, animal studies are starting to shed light on this paradox. In 2017, Hesham Sadek at the UT Southwestern Medical Center in Dallas, Texas, and his colleagues reported a peculiar finding. They kept mice in a chamber with slowly diminishing oxygen levels and noticed that if they spent 2 weeks breathing air with 7% oxygen, roughly equivalent to what each breath delivers on top of Mount Everest, their heart cells started growing and dividing. This was surprising because the hearts of adult mammals can't usually form enough new tissue to regenerate themselves, which is why heart attacks are so deadly. Sadek knew that mammalian hearts are able to regenerate themselves in utero but lose this capacity shortly after birth. He began to wonder if this might be related to the peculiar oxygen environment experienced by embryos. Although they receive oxygen from their mother via the placenta, their heart grows under largely hypoxic conditions. And if you injure it, it regenerates completely, says Sadek. Babies lose this ability soon after birth, when they start breathing, which floods the body with oxygen. He speculated that this process might be reversible, that by carefully withholding oxygen, mature heart cells could be prompted to regress to a more embryonic-like state where they start dividing. Sadek isn't alone in spotting that hypoxia may have benefits. For the past few years, a team led by neuroscientist Gordon Mitchell at the University of Florida has been limiting the oxygen intake of people who have had a spinal cord injury. They might, for example, breathe regular air for 1 minute, then air that's as thin as at the summit of Mt. Denali, the highest mountain in Alaska, the next, says Mitchell. Because of their injuries, these patients need ventilators to help them breathe, but consuming thin air seems to make them less reliant on them. Their ability to walk and grasp objects also improves. Mitchell's team has been investigating why this happens. One discovery is that hypoxia triggers the release of growth factors that fortify neural connections. The neural pathways between the brain and spinal cord strengthen, says Mitchell. Clinical trials are underway to test this further. There is also some evidence to suggest that hypoxia can spur the growth of new blood vessels around the heart. That may help explain why living at high altitude seems to reduce the risk of cardiovascular disease. Intermittent hypoxia treatments may help reduce cognitive impairment associated with neurodegenerative disease too, according to a review of several early-stage trials published in May. We are beginning to see efforts in other clinical disorders including ALS, MS, and stroke, although none of these initial pilot studies have been published yet, says Mitchell. Proponents believe the benefits may go further still. One area of interest is weight loss. This is rooted in research showing that people who live in mountainous areas are less likely to be obese, and that lowlanders who frequently go mountaineering often lose weight. Is that because people who prefer to live in the mountains tend to be more physically active, or simply that climbing a mountain is strenuous work? Partly, perhaps. But researchers say there is more to the story. In 1985, the U.S. Army simulated a 40-day mountaineering expedition in a hypoxia chamber. 6 volunteers were kept warm and provided with unlimited snacks and meals. They could also exercise, but only if they felt like it. As with Dujmovitz and Hansen's stay at the DLR, oxygen levels were gradually reduced until the air was as thin as at the top of Mount Everest. On average, the participants lost 7-5 kilograms during the 40 days. Something similar was observed when researchers recruited a group of men with obesity to spend a week living in comfy quarters at 2,650 meters. Although they didn't exercise and ate as much as they desired, each slimmed down by around 1.3 kilograms. Researchers believe that hypoxia induces weight loss in two ways. First, it seems to make people less hungry. The reason is as yet unclear as yet, but in this study, researchers found that participants produced more of the satiety hormone leptin at altitude. By the end, they ate 730 fewer calories than usual per day. Second, hypoxia also seems to trigger hormonal changes that boost our metabolic rate, so we burn more calories. It can increase energy expenditure by 30% or more. That's not to say everyone should head to the mountains if they want to lose weight. For one thing, the effects of hypoxia seem to fade when people are no longer exposed to it. A weekend at a ski resort is unlikely to produce lasting weight loss. It is also not clear how much oxygen should be withheld, and if the same amount would apply to everyone. Ultimately, hypoxia is probably a double-edged sword, beneficial in some situations, undeniably harmful in others. For people with sleep apnea, for instance, it is surely the latter. The condition causes breathing to repeatedly stop for up to several minutes at night, and many people with sleep apnea go on to develop diabetes. That may be because hypoxia triggers changes in glucose metabolism that make them more susceptible to the disease. More experiments are clearly needed, which is where Dujmovitz and Hansen come in. Inspired by Sadek's mouse studies suggesting that hypoxia strengthens the heart, Ulrich Limper and his colleagues at the DLR wanted to test the effect of prolonged hypoxia on healthy individuals, before eventually trying it on people recovering from a heart attack. Breathing thin air led to pronounced changes in the mountaineers' bodies. Their heartbeats became irregular. Blood thickened from the extra red blood cells churned out by their bone marrow, veins in the brain swelled and their hearts shrank while its walls grew thicker. Most of these changes reversed once they returned to breathing normal air. For their part, Dujmovitz and Hansen seemed relieved when they stepped out of the windowless chamber, back into normal air. The first thing I noticed about being outside after 5 weeks is that outside is big and busy, reported Hansen on her blog. With lots of oxygen. It tastes good. Further studies had been held up by the pandemic. But if things go according to plan, the work should resume soon. Now that we know that healthy individuals can tolerate this kind of hypoxia without real risk, we need to show that heart patients can, too, says Limper. He and his team have recruited volunteers who have had a heart attack and are willing to spend several weeks in the low-oxygen chamber. Like the mountaineers, they will be slowly starved of oxygen, that irreplaceable stuff that cells need to function, to produce energy, to live. Limper hopes that precisely because oxygen is so essential, the body will find a way to fight back and people will emerge fitter and healthier, out of thin air.